Okay, just continuing my videos here on the 2020 paper, but modified a little bit to facilitate us and where we are in our studies at the moment. This actually says f prime of x, but just think of it as a function for the moment, is equal to 3x squared plus 2kx plus 15. Find k if f prime of 3 is negative 12. So f prime of 3 will equal to 3 times f prime does this. 3 times the input squared plus 2k times the input, which is 3 in this case, plus 15. And we're told the value of that is negative 12. So multiplying everything out, 3 squared 9, 9 3 is 27, 27 added to 15, that's 42, plus 6k is equal to negative 12. Subtract 42 from both sides, I'll get 6k is equal to negative 54. Dividing on both sides by 6, k will be negative 9. So that's A. B says, hence solve f prime of x equals 0. F prime of x, now I'm just going to update my function. It's 3x squared plus 2kx, well k is negative 9, that's minus 18x then. 2k will be negative 18 plus 15. I want to solve for that equal to 0. I'm noticing that every term on both sides is divisible by 3, so the same solutions to x squared minus 6x plus 5 equals 0. Okay, notice that's a single x squared. The sum of the roots will be 6, the product of the roots will be 5, so x will be 1 or 5. X is 1 or x is 5. Okay, you could factor that and write it out. You could use the minus b formula, but I'm noticing that if the leading coefficient is 1, well then the sum of the roots has to be the opposite to negative 6, which is positive 6. Product of the roots is 5. The only two numbers that satisfy those conditions are 1 and 5. Okay, hence 5. Find the value of k for which 3 comma k lies on the line containing 1 comma 15 and 5 comma 17. Okay, a couple of different ways to go about this. Find the value of k for which 3 comma k lies in the line containing 1 comma 15 and 5 comma 17. I could find the equation of the line and investigate whether the point, how k satisfies that equation, or how 3 comma k could be on that line. But if it's on the line, well then the slope between any two of these points, any two of these 3 points should be the same. So I'm going to say the slope between 3 comma k and 1 comma 15. And I find the slope y2 minus y1. The change in y will be 15 subtract k over x2 minus x1. That's 1 subtract 3. So that slope there containing these 2 points should be the same as the slope containing these 2 points. If they're all on the same line, collinear, they'll have a common slope. 17 subtract 15 all over 5 subtract 1. And I've got a little proportion here that I'm going to solve. Two single fractions are equal. Just simplify everything a little bit. 15 minus k is equal to negative 2. And over here I'm going to get 2 on the top, 4 on the bottom. Cross multiply. 4 times 15 minus k, well that's 60 minus 4k, must equal to negative 2 times 2 and negative 4. Adding 4k on both sides, adding 4 on both sides, I'll get 4k is equal to 64. Which means k must be equal to 16. So the value of k that will make those 3 points all collinear will be k is equal to 16. I've used slopes there. If 3 points are all on the same line, then if I take any of those 2 points, the slope between those 2 points should all be the same. Okay, slope between all 3 pairs of points, this one and this one, or this one and this one, or this one and this one, they should all be the same. Okay, what is that slope? Well, that slope would be 2 over 4. negative or positive 2, or positive a half, I should say. Okay.